All right, today we are starting section 510. Feels like chapter 5 just lasts forever. We are going to factor by grouping. So remember we had on our flow charts that if there were 4 or more terms, we would factor by grouping, but we hadn't really talked about it yet. Today is that day. So we're going to factor a polynomial by grouping terms. For our warm-up, we need to write the opposite of each expression. Who can raise their hand and tell me what the opposite of negative 4a is? Natalie?
4a.
Positive 4a or just 4a. Number 2 gets just a little bit trickier. What about the opposite of negative 4a plus 1, Kian?
4a.
Very good. We have to switch both signs. So the opposite would be positive 4a minus 1. What about the opposite of a minus b? May?
Negative a plus b.
Very good. Negative a plus b. Again, both signs had to change. And we need the opposite of 3x squared minus 2x plus 5. Jakeem? Very good. All the signs change when we take the opposite. All right, on 5 and 6, these should be familiar to us. We have to find the GCF and factor it. So on number 5, can anybody tell me what the GCF is? Ryan? 5, I would agree. That's the biggest number that will divide into both of those terms. So when I factor a GCF, where does it get written? Outside a set of parentheses. Good. And what goes in those parentheses? Keon? 4x minus 1. So remember, even though those 5s reduce or cancel each other out, we still have to put a minus 1 there. Otherwise, we're changing the problem if we just leave it off. All right, number 6. A little bit trickier with the GCF. Anybody find it? Jamal? 4. Anything else that goes with that 4? An x, good. We had some friends help us out there. Both of those terms have at least one x that they can contribute to our GCF. So we would factor out a 4 with an x. Again, our GCF is written outside parentheses. Who can tell me what's left when we factor that GCF? So after we factor out that GCF, we're left with 2 plus 3x. Questions about our warm-ups? All right, I know this is a little small, maybe hard to read from the back. It says a key tool to factoring polynomials involves the distributive property. Key tool to factoring polynomials involves the distributive property. And then in the middle there, it says BA plus CA equals, and we've got to fill in that blank afterwards. So it's A parentheses B plus C. I'll write that a little bit bigger. A parentheses B plus C. So they factored out the GCF of an A. Both of those terms had an A. Remember, factoring is writing things as a multiplication problem. So it's kind of like undistributing. Then it says, for example, if a is equal to x plus 2. So they want us to rewrite this whole line. Instead of using an a, I'm going to use x plus 2 in parentheses. So we'll rewrite it together. So b, and then instead of an a, I'm going to write an x plus 2 plus c. Instead of an a, I'm going to write another x plus 2. So this is showing us that we can factor out more than just one term. We can factor out a set of parentheses. So equals, again, instead of this a, I'm going to put my x plus 2 and then my parentheses b plus c. So what this is showing is that we have a set of parentheses that acts as our GCF. It's a little bit different from what we've seen before. And once we took out that set of parentheses, what was left was b plus c. All right, they start us off pretty easy on this first example. We are asked to factor 5 times x plus y plus w times x plus y. So usually when we would see something like this, our instinct would be to distribute, but we don't want to do that because that will get us further away from our answer of factoring. So we're trying to write this whole thing as just one multiplication problem. Remember, that's what factoring means. Write it as a multiplication problem. So I really have 2 terms here. I have a term before the plus sign in the middle there, and I have a term after the plus sign in the middle. So if we are factoring it, I want to know what they have in common so I can factor it out like a GCF. What do they have in common?
X and Y.
The x plus y. So that piece that's in the parentheses is in common for both of them. You see that? They both got x plus y in parentheses. So that's what gets factored out. Now when we factor out a GCF, where does it get written? In front of parentheses. So even though our GCF is in parentheses, x plus y, there's going to be another set of parentheses because that's where GCFs get written. What goes inside those parentheses is what's left after we divide by the GCF. So if we divide by x plus y, those reduce, and what's left?
0.
Not a 0. The 5 that was out in front here. We're going to do the same thing to our other term. We divide by our GCF, and what do we have left? A w, and it is positive, so we write plus w. And that is how we factor by grouping. Now, they made the groups for us, which is a little bit nicer, but we were able to factor out what they had in common. Questions about our first example? Okay. Next one, m times m plus 4n minus m plus 4n. So if it helps to kind of box your terms, you can, but who can raise their hand and tell me what these terms have in common? Or do we need to go to our sticks? I'm seeing the same hands calling on the same people. Jalen, what do you think? What do they have in common? They do have the same variables, but a little more specifically, what part matches on both sides of the minus sign? What's in the parentheses matches. That's exactly the same. M plus 4n, m plus 4n. So that's what we consider to be our GCF. So we're going to divide both of these by that GCF. Where else do we write a GCF? Where else do we write a GCF? I keep hearing parentheses. What about parentheses? Out in front of some parentheses. So m plus 4n out in front of some parentheses. What goes in those parentheses is whatever is left over. So in the front, Keon, what's left in the front? Okay, well, that's the whole thing, not just the front. But yeah, so what's left in the front is an m. We have a minus sign in the middle. In the back, those completely cancel out. But kind of like we saw in one of our warm-ups, we can't just leave it blank. So if you divide something by itself, that equals 1. Questions about example number 2? Okay, that is our answer on that one. So we'll move on to number 3, where it gets a little bit more interesting. So on number 3, it says use blank for opposites. So when we have opposites, we are going to use a negative sign or use subtraction, however you want to word it. So I like to say use a negative or use subtraction would be another way of saying it. So let's see what that kind of means for us. Okay. On our parentheses, do these parentheses match the way that they're written right now? No, they do not. So what I would recommend is rewriting this, but if we switch these signs or switch this around, we're going to have to use subtraction or change the sign in the middle. Use a negative. So if you take a negative of a negative or you subtract a negative, what does it turn into? A positive. So let's just rewrite this before we try to factor it. The front, we're just going to leave alone. But if I change the back to be a -3 plus a, okay, I changed these two signs back here. This has to become a positive 2a there. The front part didn't have to change. We didn't have to do anything in the front. But it's kind of like we factored out a -1 in the back. So we had to change that sign. Now, if you need to rewrite it again to see how it rearranges, my a is now positive, my 3 is now minus, so I can rewrite it as positive a -3 in those back parentheses, and now it matches completely. Now, if you were to do these two things all in one step, that's fine. I just wanted to show you exactly where this comes from. Do we have questions about changing the signs in one set of parentheses? Deja? So we had to change the sign so that these parentheses matched, because if the parentheses don't match, you can't factor it out like we were doing before. Does that make sense? They got to be exactly the same for it to factor. It's a good question. Do we have any others? Okay, so now let's factor this like we were doing before. Now that we've changed it, Kelby, what is my GCF, so to speak? The a minus 3. So I'm going to divide both pieces by the a minus 3. And we've said it also gets written out in front of what? Another set of parentheses. Now I need to know what goes in those parentheses. Jamaro, what do you think goes in those parentheses? Very good. Whatever's left over when we divide. So in this case, those cancel out. We're left with a 5 plus, and then the 2a in the back is what's left over when the a minus 3's cancel out in the back. Final answer. Questions about having to use subtraction or use opposites? Okay, let's try another one. Are we going to need to use opposites on number 4? No. How do we know that? We don't need opposites because our x plus y already match. They're already exactly the same. They've got the same signs. We don't have to rearrange them at all. So that's what they have in common. That's what we are going to factor out. So I'm going to write my x plus y in front of more parentheses. We need another set of parentheses now. Jamal Dixon, what goes in those parentheses? Very good. Whatever's left over. So in this case, that would be a 3 plus z. Questions, concerns? That's all we got to it. Factor out what we can. That's all that can be factored. We got to leave it alone. All right, on number 5, are we going to need to use opposites?
No. Oh, yeah.
Who can defend their answer?
What was the question?
Do we need to use opposites? Keon says yes, but he changed his mind.
No.
Kion says no. Danielle says yes.
No.
Jayshawn says no. Who can defend their answer?
It's different. Yeah, it's different on ours.
It's different on yours.
Yeah, R minus S for both.
Oh, dear.
Both of them say R minus S.
Oh, that would make it different. All right, we'll go with what's on your paper. I'll change mine. So if we go by what's on your paper, do we need to use opposites? No. So we'll change it to match your paper. That's fine. I'm sure we'll have other ones where we need them. Okay, so on your paper, if it says R minus S for both, we do not need opposites because they are already the same. They already match. So what is my GCF? R minus S. Those parentheses that match are my GCF. Hopefully we're getting the hang of how this process works. We also have to write this where? In front of some parentheses. And then I need to know what goes in those parentheses. Ryan, what do you think?
7 plus t.
Good. 7 plus t. So we cancel out that GCF that we divided out. We're left with a 7 plus t. Final answer. So this is just like doing GCFs. It's just that our GCFs are now in parentheses instead of just one term at a time. All right, this problem is a little more involved. We are going to have to factor in the front. We're going to have to factor in the back. And then we're going to have to factor the whole thing. We got 3 times the amount of factoring to do. So the first thing that I want to focus on is just this first set of parentheses. It's the only thing I'm looking at. So I need to know what my GCF is just inside that first set of parentheses. Houston, what do you think? What do those 2 terms inside those parentheses have in common? 3t. So just for this set, I'm going to factor out a 3t. Now when I factor out a GCF, it gets written in front of parentheses. What we put inside this first set of parentheses that we made is whatever's left when we factor out that GCF. Deja, what's left when I factor out that 3t? So if I take 3t divided by 3t, if you divide something by itself, what are we left with? The t's are getting divided too.
Yes. 0.
If you take 3 divided by 3, what do you get? A 1. So it's the same thing if you put a t on the top and bottom. We're left with a 1. And in the back here, what are we left with? I asked Deja to help me with this part. We're left with an S in the back. The sign in the middle was a minus. We didn't change that, so we'll keep it the same. Questions about factoring out a GCF in the front part? All right. In the back set of parentheses, so we're switching gears. We're moving to this back set. I am going to drop down that plus sign because I'm not going to factor out a negative just yet at least. And I need to know what my GCF of the back set of parentheses is. Jay Sean, what do you think?
What?
What's my GCF of this back parentheses?
R.
The R. So we are going to factor out an R. It also needs to get written in front of a set of parentheses. And then I have to know what's going in those parentheses. Nevaeh, what are we left with just back here when we factor out an R?
Wouldn't that be S minus 1?
S minus 1. Very good. Questions about those first couple steps of just factoring GCFs out of those parentheses only? Okay, then we have to move on and see if we can factor out more, just like we started doing today. So this is us grouping. Now, are we going to need to use a negative or opposites in order to continue? Yes. How do we know? Okay, our parentheses are not exactly the same. First of all, they're in a different order, but they also have different signs. Here, my 1 is positive. Back here, it is negative. Here, my S is negative. Back here, it's positive. So we got to change one of them. Usually, we like to change the back set. Technically, you can change either, but if it's a good habit to just do the same thing every time. So we are going to leave the front alone. 3t times 1 minus s. If I'm going to be changing signs in my parentheses, it also has to get changed out in front of those parentheses. So instead of a plus r, this is going to become a minus r. So I'm flipping all 3 signs back here. Changes to a minus r. This is going to be a minus s, and it's going to be a positive 1. Now this time I changed my order when I changed my signs to save me a step. If you need to do that one step at a time, that's fine. Are we okay with changing the order and the signs at the same time? If you need to, you could write it off to the side. It would be minus r times negative s plus 1, and then all I did was flip-flop my positive 1 and my negative s. We okay with that? Are we done with this problem? No, we are not. So the next step is to factor out another GCF. Kion, what can I factor out now? The 1 minus s. So I'm going to divide both sides by the 1 minus s. That is also going to get written in front of a set of parentheses. And then I just need to know what's going in those parentheses. Franklin, what do you think?
2 minus r.
And I agree with the minus r part, but I would double check the
3.
front. 3, what's with the 3?
T.
Good, 3t minus r. So just whatever's left over when we cancel out those sets of parentheses that factored out as a GCF. We're sure we're feeling good about this? That's a long problem. We get all our steps written down? Ready to keep going? Okay. Jay Sean is speaking for the group. All right. Now, this is leading us slowly into our grouping. So this time, they did not put parentheses around part of the problem. But we can add parentheses to be able to make a group ourselves. So we are going to add some parentheses in the front here. We are making a group. We made our group. So we are putting parentheses around the front to make a group so that we can find a GCF. Eventually, you'll see problems where there are no parentheses at all, and you'll have to make all your own groups. That's what we're leading up to. So now that we made our group, we have to decide on a GCF in this first set of parentheses. Lexi, what do you think it is? There is definitely an x involved. What number could 12 and 8 both be divided by?
4.
A 4. Very good.
4.
So we are going to divide both of these by a 4x. That's our GCF in the front. A GCF always gets written in front of parentheses. So then we have to know what's left in that group. Connie, what's left when I factor out a 4x from both of these two terms? So let's do it one piece at a time. 12 divided by 4 leaves me with 3. Thank you, Connie. X squared divided by x leaves me with what? Sorry, Connie. So x squared divided by x leaves me with what? We got the 3. Just an x, so an x goes with the 3. We're going to drop down the minus. Now, Connie, when I divide 8 by 4, what do I get? 2. And the last piece, those x's cancel, but there's still what other letter? A y. Questions about making our first group and factoring from it? All right. Then in the back, we've got a minus 5. But we need to check that second group that they made for a GCF. Is there a GCF in that second group?
Z.
Yes, they both have a Z. So we are going to take that Z and put it out by this minus 5. We've still got those parentheses there. So we need to know what's going to be left inside of them. Deshaun, what do you think? What'll be with the x? So what's left in here if we cancel those z's out? What's still in here? 3 with a 4x minus, what's in the back, Deshaun, if we cancel out those z's? 2y. Now, what do we notice about those sets of parentheses? They match, which means we can factor even more. That's the whole goal. We want sets of parentheses that match each other so that we can divide it out or factor it out from both terms. So now I'm going to factor out that whole set of parentheses, 3x minus 2y. And then I need to know what's going to be left when I factor it out. Danielle, what's left? Very good. 4x minus 5z when I cancel out those sets of parentheses from factoring. So there is my answer. Question. All right, on number 8. Did they make any groups for us? No, we have to make all of our own groups. So usually when we do this, we split it in half. So the first 2 terms go in a group together. We're going to leave that plus sign alone, hanging out in the middle there. And the second 2 terms become a group together. So we are doing the grouping all on our own now. Been building to this for the last 30 or so minutes. Now that we have our groups, we have to factor out GCFs from them. So I need to know the GCF of just my first group. Jakeem, what is it? What do these 2 terms in my first group have in common? So I can factor out a 3p from my first group. A GCF gets written in front of some parentheses. And I have to know what's left over. Natalie, what's left over if I factor out that 3p? 3 minus 1q. I'm just going to put a q. If you like the 1 in front of your q, that's also okay. So here the p's canceled out totally. We're left with a 3 minus the 3 and the p both canceled out. We're left with the minus q. In the back, I'm going to put a plus. And then we have to decide our GCF for the second term. Second group, I should say. May, what's our GCF for the second group? Good. So this back set of parentheses, we can factor out a 2n from both of those. So it gets written outside of its own set of parentheses. Who can tell me what's left? Keon? Good. Q minus 3. Now, in order to move forward, we would need our parentheses to match. Do they? No. So what can we use? We need to change the sign. So if we're going to change the signs back here, where else does the sign change? In the middle. So we leave the front alone. 3p times 3 minus q. The sign in the middle changes to a minus 2n. And then in the back, the signs are also changing. So my q becomes negative, and I'm going to move them to the back. The 3 becomes positive, and I'm going to move it to the front. Now that our parentheses match, we can factor some more. So now we're going to factor out that set of parentheses, 3 minus q. So for our final answer, we've got 3 minus q out in front of another set of parentheses, and I need to know what's going in that back set of parentheses. Somebody other than Keon needs to know. Kion.
Is it 3p minus 2?
Beautiful. 3p minus 2n. It's whatever's left over after we divide out that set of parentheses that matched. So the 3p minus 2n. Final answer is over there. Remember, when we factor, we write things as multiplication problems. All right, we got one more that we need to get through. We are going to set up our groups. Remember, when we set up our groups, we need to use parentheses. These problems are all about using parentheses. Parentheses when we make groups, parentheses when we factor. Now that I've got a group set up, I need to find its GCF. What's my GCF in my first group? 2a, I would agree. We can factor a 2a from those groups. What's left when we factor out a 2a? B minus 3c. I agree. I'm going to drop that plus sign from the middle down. What's my GCF of my second group? A 3, not a variable, just a number. And what's left when I factor out a 3? Another b minus 3c. Now that's nice for us because now our parentheses match. We don't have to do anything to change them. So now what am I factoring? A GCF of b minus 3c. I like that wording. So our GCF gets written in front of another set of parentheses. And what goes in that set? 2a plus 3. And that's it. We made our groups. We found a GCF of both groups. Found a GCF of both groups. And then we were able to find a GCF of a set of parentheses and factor that out for our final answer. All right. We have some try these problems. We might be able to review those on Wednesday when I see you again. But before Wednesday, you better get this homework done because you got 2 whole days to do it. Page 225, 226, 2 through 30 evens. Remember, we do the written exercises.